Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazogai is going to deal with fluid mechanics. So in previous class we have seen dimensionless numbers in dimensional analysis. Now today we are going to start with a new topic known as a centrifugal pump. So in this chapter we are going to discuss very first in today's lecture introduction to centrifugal pump, then parts of centrifugal pump, then types of impeller, types of casings, suction pipe and delivery pipe. And at the last we are going to discuss heads, that is suction head, delivery head and static head. And finally we will see the priming of pump. What is necessity of priming a pump and what is the meaning of priming of pump. Now, so what this centrifugal pump is? Generally centrifugal pump is nothing but a power consuming machine. So what this power consuming machine is? So we say there are two kinds of machines. One machine is known as a power producing machine. That is nothing but the internal combustion engine, turbines or electrical motors or steam engines are power producing machines. Then certain machines use this power produced for doing certain work, and those machines are known as a power consuming machines. So the compressor, air compressor, is a power consuming machine which is not producing power, it is going to consume power and is going to compress the air. Similarly, centrifugal pump is also a device which consumes the power and converts this power or work into hydraulic energy or pressure energy. So now what is function of a centrifugal pump? So generally centrifugal pumps are operated by primers. Nowadays these centrifugal pumps are operated by electrical motor. In previous olden days these centrifugal pumps were operated by engines. So now the function of this centrifugal pump is to convert mechanical energy supplied to the pump into hydraulic energy. So the energy which is supplied to the pump is in the form of mechanical energy, that is work, and that is converted into hydraulic energy, and that hydraulic energy is nothing but converted into pressure energy. So hydraulic energy is converted in the form of pressure energy. So this is the function of centrifugal pump. In order to raise the water from lower level to the higher level, some work is to be done, and that work is supplied through this centrifugal pump to this water or liquid which is lifted from a lower level to the higher level. So centrifugal force acts to convert the energy. So what this centrifugal force is? So when some mass is going to rotate about the center, so this mass, so when it is rotating at speed n rpm, so mass m, when it is rotating about a particular center, so when this mass is released from this distance, so this will acquire the velocity v, which is in tangential direction, and the force which makes this mass to move away from the center of rotation is known as a centrifugal force. This moves with the force known as a centrifugal force. So centrifugal force is acting on this mass which is rotating about the center. So this centrifugal pump works on this principle of centrifugal force. So due to this centrifugal force, the mass is thrown away from center of rotation. So here water is thrown away from center of rotation. So this centrifugal pump works in the reverse direction or reverse way of inward flow reaction turbine. So you might have not studied the reaction turbine. So this is exactly working of the centrifugal pump is exactly opposite to the reaction turbine, inward flow reaction turbine. So now this centrifugal pump works on the forced vortex principle. So what this forced vortex is? So where the forced vortex means when certain mass of liquid is rotated by external torque, the rise in pressure head of rotating liquid takes place, and this rise in pressure head is the aim of this centrifugal pump which converts this mechanical energy into rise in pressure head. Then the rise in pressure head is proportional to the tangential velocity. So this pressure head is directly proportional to the square of tangential velocity. So as I told you, so when this mass is moving away from center of rotation, so at velocity v it is released. So this pressure head which is going to rise is directly proportional to the square of this velocity, tangential velocity. Then the high pressure head helps to lift this liquid to high level. So when this mass of liquid is thrown away from the center of rotation, then this is going to convert this velocity into pressure head, and this pressure head, which is produced by forced vortex, is responsible to raise this liquid to higher level. Then parts of centrifugal pump. What are the parts of centrifugal pump? There are four main parts of centrifugal pump. Very first part is known as impeller. Then this impeller is enclosed in a casing, that is cover, which is known as a casing. Third part is known as a suction pipe with footwall and strainer, and fourth part is known as a delivery pipe. We will study one by one what impeller is, casing is, suction pipe and delivery pipe. Now very first, this is an impeller. So what this impeller is? This impeller is made of casting or cast iron. In earlier days, cast iron or aluminium. So nowadays these impellers are made of fiber. So these impellers are nothing but a rotating part in a centrifugal pump. So these impellers contain the vanes, series of vanes. So this part is known as a vane. So there are multiple number of vanes are over this impeller. So these vanes are in a backward curved direction, curved portion. So this curve, these are curved in shape, and this is backward curve, means this impeller rotates in this direction, and these are turned in the opposite direction. So therefore these are known as backward turned vanes, series of vanes we can see. So now we can have here one circle which is touching to all these vanes. So this is inner circle having diameter d1. So this has got diameter d1, which is inner circle, or we call this as an inlet, so through which water enters. And if we trace a circle at the outer edge of these vanes, so this is called as the outer circle or outer diameter of this impeller. And we can see here the area of cross section between two vanes. So if you see this distance at the inlet, so water starts to move in this direction along this passage. So this water flows in this passage. So the area of cross section at the inlet is small, and this area at the outlet is going to be larger. So this is the distance between two vanes at the outlet, whereas the distance between two vanes at the inlet is smaller. So this area is going to increase gradually as this water flows from inlet of impeller to the outlet of impeller. So this is outlet of impeller, whereas this is inlet of impeller. So this area is going to increase. So this depth we call as a width of impeller. So here from this base to this tip, so this distance we call as a width of impeller in future. So that we call as a B. So this is the impeller, which is a revolving part. So rotating part of a centrifugal pump is known as a impeller. So this impeller is mounted over a shaft. In this hole, a shaft is placed, and that shaft helps, or that shaft makes this impeller to rotate. So that shaft is rotated with the help of an electrical motor or engine, and which is connected to the impeller. So therefore this impeller starts to rotate along with the shaft, so which is inserted into this hole. So it is made of number of vanes. Vanes are backward curved vanes and mounted on the shaft. So shaft is connected to the prime mover. Prime mover can be the electrical motor or engine or steam turbine, whatsoever it is. So it is the rotating part. It is the heart of a centrifugal pump, which converts mechanical energy into hydraulic energy and pressure energy. As the water enters at the inlet of this impeller, so when this water moves from inlet to outlet, so this cross-sectional area is going to increase, and this converts this kinetic energy into pressure energy. Gradually it is converted into pressure energy. Hydraulic energy is converted into pressure energy as this water flows or liquid flows through these passages between vanes. Now second is that we see is types of impeller. So there are three types of impeller. Very first is open impeller. So in this open impeller the vanes are not covered on any side. So just now what we have seen is the impeller having one side cover. So this is purely open impeller where we do not have any cover on either side of this blade. So here there is no cover on the upper side as well as on lower side. So then second one is semi-open impeller. So what is semi-open impeller? So just now whatever we have seen, the previous image was the image of semi-open impeller. So there was one plate on one side. So you can see here. So this is the plate on one side. So therefore we call this as a semi-impeller, semi-open impeller. This is open impeller. So what is the difference? What happens? So here if the impeller is completely open, so back leakages are going to happen and that is going to reduce the head and there is a loss of energy. So the head which we desired head cannot be attained and efficiency of pump gets reduced. So to improve efficiency, semi-open impellers are introduced. So thereafter they have introduced the closed impellers. Closed impellers have got the cover on both sides so that back leakages are reduced and because of which efficiency of pump is increasing. Nowadays all the pumps, centrifugal pumps are with closed impeller. So rare manufacturers are going to use semi-open impellers and open impellers are not at all used nowadays. So this is the image of closed impeller. So we can find two covers on both side of vents. So through this the water enters. So this is the inlet and the water comes out from the circumference of impeller. Now we see what is the casing. So what this casing is, it is nothing but a cast iron body or it is a casting and which encloses the impeller. So impeller is placed in this. So this is the cavity in this impeller is placed and there will be one cover which is going to close this casing. So this casing supports to this shaft. So this cover which is going to be close this part is going to hold the stuffing box which avoids the leakages. So this is an airtight vessel and on other side, so we can see one hole here. So this is the inlet hole. So to this side hole on other side the pipe is connected, that is known as a suction pipe, and this upper part is known as a delivery section where the delivery pipe is connected. And you can find this the area of this casing is going to increase as the water starts to flow from inlet. So this is a spiral shape casing and this area of cross section is gradually increasing with the flow of water, and here you can find this area increased. So this helps in reducing the velocity and increasing the pressure of liquid flowing through this casing. So now this is similar to the casing of reaction turbine. Then it is airtight passage where it encloses an impeller inside it and the supports to the shaft. It supports to the shaft and converts kinetic energy in the sense velocity of water into pressure energy. So this is happening because of increasing area of cross section. So next we see types of casing. So there are three types of casing. One is volute casing and second one is vertex casing and third one is casing with guided blades. So now we see one by one. So very first volute casing, just now we have seen the cross sectional area is going to increase gradually. So this is a spiral type of casing and this inner part is nothing but a impeller. So you can see here, so this impeller is going to suck the water and that water is thrown away from this impeller into the casing, and this area of cross section, the space between impeller and casing is gradually increasing as we move away from this. So water flows in this direction or liquid flows in this direction. So area of cross section is gradually increasing. So that converts this kinetic energy into pressure energy, and then it is delivered to the delivery pipe. So this is the case where we see first kind of casing known as volute casing. So here what happens, there is a efficiency of volute casing is less, because this water which comes out will form the eddies. So it starts to rotate in this gap and eddies are formed, and because of eddies the head is lost or energy is lost. So now it surrounds the impeller, that means it covers the impeller, and it is a spiral type in nature, whereas flow area gradually increases. As I told you, as we move along this direction, the flow area is going to increase, and the increased area helps to reduce velocity and increase pressure. So reduced velocity results in increase of pressure. So now we see vertex casing. So vertex casing is similar to this volute casing. So area again here is going to increase, but there is one vertex chamber. So this barrier is provided. So this barrier which is provided, which obstructs to formation of eddies. So in previous case there was a demerit, or there was a chance of forming eddies. So that formation of eddies is obstructed by introducing a vertex chamber. So here there will be a perforated partition that obstructs to the formation of eddies. So this is the difference between vertex casing and volute casing. So it is a circular chamber is introduced between impeller and casing. So this is the casing and this is the impeller. In between impeller and casing, so there is a chamber is introduced. This is a perforated opening passage, and which obstructs to the formation of eddies. So loss of energy due to eddies is reduced because of this circular chamber, and efficiency of pump is improved. As the loss is reduced, definitely output is going to increase, and therefore efficiency is going to enhance. Now casing with guided blades. So this is another concept. So this inner part is known as an impeller, as we have seen. So this is the impeller. So the area of cross section starts to increase from inlet to outlet of this impeller as this water moves. So as soon as this impeller is a rotating part, so guiding blades or guiding vanes are stationary. So another part, just like impeller is placed after this impeller. So this impeller is a rotating part, whereas this guided blades are stationary part or stagnant part. So when this water comes here, so that is passed into this casing with guided blades. So these are called as the guided blades. So when it enters into this guided blade, again the cross-sectional area of guided blade is increasing. So from inlet to the outlet, so area is going to increase, and the velocity is converted into pressure. At the same time, the risk of formation of eddies is also reduced. So this is another type of casing which is introduced, consists of guide blades. We call this as guide blades. So this part from this to this is guide blades. So these are the guide vanes, we call as a guide vanes. So impeller is surrounded by guide blades, and guide blades are mounted on a ring. So this is a ring, and this ring is known as a diffuser. So this part is known as a diffuser, we call as a diffuser. And water enters the guide vanes without shocks. So when water enters in this part, it is going to enter without shock, because there is a very less clearance and it enters without shock. So area of guide vanes also increases. So at inlet area is less and at outlet area is more. So that helps in increasing the pressure or converting kinetic energy into pressure energy. So increase in the area increases the pressure. Then we move for the another part known as a suction pipe with foot wall. So what this suction pipe is? So the pipe which connects the eye of casing. So this is connected to the eye of casing, and one end is connected to the eye of a centrifugal pump, and another end is submerged into the water, and to another end there is a foot wall or strainer is fixed. So this foot wall helps to hold water during priming. So when we are going to prime this pump, so this is going to help us to hold this water. This is kind of non-return wall. This is kind of non-return valve, so holds the water in this suction pipe. So why we need to hold water in suction pipe, that we see in the priming. So this is nothing but the suction pipe. So it is, one end is connected to the inlet of casing, so this is one end, and to another end the foot wall is connected and it is submerged into the water, and this foot wall is nothing but kind of non-return wall. So strainer is connected at the lower end, so to give certain strength to this suction, strainer is provided, that is nothing but a spring adjustment is there. So then we see delivery pipe. So what this delivery pipe is, so from this casing the pipe is connected to this centrifugal pump, and this pipe which is connected at the outlet of casing to the location where this water is to be discharged or delivered. So this complete length of pipe is known as a delivery pipe. So it is connected to the outlet of casing, and another end is extended to the discharge location where we want to discharge this water. Up to that, the pipe is known as delivery pipe. Now heads, there are various heads. Which are the heads that we have to study? Very first head is suction head, that is we will see, then delivery head, and then static head and manometric head. So today we are going to study only three heads, that is suction head, delivery head and static head. So manometric head we will discuss in next lecture. So next we see what this suction head is. So it is a vertical distance from the center of impeller to the free surface of water or liquid in the sump. So this vertical distance from center to this free surface is known as a suction head. It is a vertical distance measured from center of a centrifugal pump or impeller to the free surface of liquid in the sump. So this is known as a suction head. So remember that this is a vertical distance, not a inclined distance or horizontal distance. So it is a vertical distance between center of impeller to the surface of water in sump, and it is represented by HS. Then delivery head. Again, delivery head is the distance from center of impeller, and this is also vertical distance measured from center of pump to the location where this liquid is lifted. So the vertical distance, not a horizontal distance or inclined distance, it is not measured, it is measured vertical distance, yeah, along the vertical or height. So this is measured from center. Okay, so this is also vertical distance and between center of impeller to the delivery location, and is represented by HD. Then we see static head. So what this static head is? So static head is nothing but sum of delivery head and suction head. Total head is known as a static head. This is also measured in vertical direction. This is the vertical distance. So it is vertical distance, and sum of suction head and delivery head is known as a static head, and it is represented by HS. Next we see priming of centrifugal pump. So what we do? So this is the last bit of today's lecture. So what is priming? So before starting, you might have seen at your farm or at your home, when you are using a centrifugal pump, initially you are going to pour water in this pump, and then afterwards you are going to open this air vent. So this is the air vent. So to remove complete air from this pump, we have to have here one foot wall at the bottom. So this foot wall is nothing but non-return wall. As I said you, this foot wall is non-return wall. So when we pour water into this pump, so this water is going to be present in this suction pipe as well as into the casing up to this wall. So this is filled with water. So why it is filled with water? What is the necessity of filling this water before starting pump? So this process of filling this casing and suction pipe with the water is known as a priming of centrifugal pump. So what is the necessity? So if as I told you, this casing is airtight. Why this is to why this needs to be airtight? So what happens if there is no water in this casing and suction pipe? So this when impeller starts to rotate, the head is developed in terms of meters of air, meters of air. And if it is filled with water, then head is developed in meters of water. So the density of air is very low and density of water is very high compared to it. So the head developed in terms of air is not sufficient to suck this water from the sun. If air is present, if we are not going to prime this pump, at that time the head developed is in terms of meters of air column, and that head which is developed in terms of meters of air column, because of lower density of air, is not sufficient to suck this water. If we fill this centrifugal pump, casing of centrifugal pump and suction pipe with the water, then when we start this pump, the head which is developed, pressure head which is developed, is in terms of meters of water, and that head is very, very high compared to the head developed in terms of meters of air. Therefore, it is possible to suck this water when we are going to fill this centrifugal pump or casing of centrifugal pump and this suction pipe with the water. It is possible to lift this water or suck this water. So these are the reasons. So work done by impeller per unit weight of liquid per second is known as head generated. So this head which is generated is independent of density of liquid, but the pump which is running in the air, the head is in terms of meters of air. When this pump is having filled with air, so the head generated is in terms of meters of air. And if the pump is primed with water, then head generated is in terms of meters of water. So head generated in terms of water is very higher than the head generated in terms of air. So this is negligible. Head generated by pump in terms of air, meters of air column, is very negligible compared to head of water. So therefore, it is impossible to suck the water which is not primed by a pump which is not primed, or priming is not done. So therefore, priming is necessary, and water may not be sucked from the pump if we are not going to fill, or even if there is a presence of air in this casing or in suction pipe. So that also will not allow us to create the sufficient suction. So therefore, here air vent is given. Then we are going to fill this with water. At that time, the air present in this casing is to be released from this air vent. So to avoid this, priming is necessary. To avoid this difficulty, priming is required. So we stop here. Thank you. We'll see the things in next lecture.